The next new lesson is states of matter. See, already you have learned in lower class level what is the states of matter. Usually, the state, that is, in a chemical substance, they decide which is the substance is solid, or liquid, or gas. So here, this is the physical states of the matter: solid, liquid, and gas. Plasma and Bose-Einstein states are there, but we are going to learn in these three states of matter, that is in physical states of the substance, the chemical substance, that is solid, liquid, and gas. Solid state we will learn higher senior secondary level, that is senior secondary second year. In this year you are going to learn liquid and gases. See here, that what are the liquid and gas? Usually, first I know that the solids, the appearance like closely packed. Solids are very closely packed. Then the liquids are like this. Compared to solid, the liquids are this. The packing efficiency is like this. Then gas molecules are like this. So it is freely packed. Here we are going to learn this is what is that liquid and gaseous state in this unit. So here what are the forces are involved here, that is the intermolecular forces, that is the nature of the intermolecular forces, molecular interaction and the effect of the thermal energy and the motion of the particle, that is because of balance between these determine the states of the substance. Here first we will learn the intermolecular forces. What is that? The intermolecular forces. Here the forces of the attraction and repulsion, that is attraction and repulsion between the interacting particles. Attraction and the repulsion. Attraction and the repulsion between the interacting particles like atoms or ions or molecules. Atoms and molecules. See here in this term, this is not does not include the electrostatic forces of attraction, that is they exist between the two oppositely charged, that is positive and the negative charged ions, and the force that hold atoms of a molecule together, that is called covalent bond. And the attractive intermolecular forces, that is attractive intermolecular forces are known as van der Waals forces. Van der Waals forces. See this the van der Waals forces, that is the considerably, that is in magnitude, and they include dispersion forces or London forces. Here the dipole forces and dipole induced dipole forces, like this. So these are the particular strong type of dipole interaction and the hydrogen bonding. So we can learn here this topic. Like first we will know this. The important to the attractive forces between the ion and the dipole are known as ion dipole interaction, that is ion dipole forces, and these are called van der Waals forces. Now we will see the different types of the van der Waals forces. The different type of the van der Waals forces here. First, London forces are the dispersion forces. London forces are dispersion forces. London forces are dispersion forces. The second one is dipole forces. Dipole forces. The third one is dipole induced dipole forces. we will learn one by one. Here, the London forces. That means atoms and non-polar molecules are electrically symmetrical. Means that is, they have no dipole moment because their electronic charge cloud is symmetrically distributed. So, but a dipole may develop momentarily even in such atoms or molecules and molecules. See, suppose we have two atoms like A and B. Atom of A and B in the close vicinity of each other. For example, we can write here atom A and atom B. Atom B. Here the electronic, that is that momently the electronic charge distribution on one of the atom says, that is A, atom A, and becomes that unsymmetrical, that is the charge cloud is more on the side, on the other side. For example, this is atom A and the atom B. Here this means the positive charges here and the positive charges here. See, the first this is the symmetrical distribution of the electronic charge. Like this is the symmetrical distribution of the electronic charge. Here that's mean that happened, that is momently the electronic charge distribution one of the atoms, that is A, becomes unsymmetrical, that is the charge cloud more on the one side than the other side, that is this type 1 and one more type is these are atom A and these are atom B. So record here the distribution, like first one is the symmetrical distribution of the electronic charge cloud, atom A and atom B. Here the atom A, that is instantaneous the dipole, more electron density on the right hand side. Here that atom B, so that the usually the dipole we have to indicate like this, arrow mark with tail like this and arrow mark tail like this. This atom B like this. See, look at here, this is the atom B with the induced dipole. Similar way here, look at this compound, the charge, the direction of this dipole moment like this, and this is also the same. Here the atom A, here the more electron density on the left hand side. The first one is the more electron density is right hand side, here the more electron density in the left hand side, here the more electron density, and the atom B with induced dipole. Look, see, the charge cloud is more on the right hand side other than this B and C. This results the development of the instantaneous dipole on the atom A for a very short time. This instantaneous or the transient dipole discharge the electron density of the other atom B, which is close to it, and as a consequence a dipole induced in the atom B. This is the dipole induced. So this temporary dipoles atom A and B attract each other, and similarly temporary dipoles are induced in the molecule also. This forces of attraction called first London forces. This forces of attraction is called London forces or the dispersion forces. Here these forces are always attractive and the interaction energy is inversely proportional to the sixth power of the distance between the interacting particle, that is 1 by r power 6. So here r is the distance between the two particles. R is the distance between the two particles. So these forces important only at short distance, like up to 500 picometer, and their magnitude depends on the polarizability of the particles. So this is called London forces or the dispersion forces. The next is dipole forces. Second is dipole interaction or dipole forces. This dipole forces act between the molecule possessing a permanent dipole, that is a temporary dipole. Here the possessing a permanent dipole, that means hence a dipole possesses a partial charge. That means the partial charge we can write like this: delta. This symbol is, the Greek letter is delta. The partial, this indicates del plus and the del minus. This is partially positive and the partially negative. So the partial charges always less than the unit of electronic charge, that is 1.6 into 10 power minus 19 coulombs. Here the polar molecule, that is the interacting with the neighboring molecule. For example, HCl, hydrogen chloride. Like this, hydrogen and the chloride. What happens here means the more charge density towards the chlorine atom, more charge density towards the chlorine atom. Here more charge density towards the chlorine. So this will be partially negative, that is del minus, and this will be a del plus. And here the polar molecule, that is the electron cloud distributions of the dipole of hydrogen chloride, and the dipole interaction between the two molecules of HCl, that is two HCl molecules. H and Cl, H and the Cl. Here this dipole interaction between the two molecules like this. Here the intensity is more and here the intensity is more, that is the del positive and the del negative, the del positive and the del negative. Here this shows the dipole interactions of, that is stronger than the London forces. Compared to that London or dispersion forces, this dipole forces is stronger. But the weaker than the ion-ion interaction, because the only the partial charges are involved. Here the only the partial charges are involved, so the attractive forces decreases with increasing distance between the dipoles. So this is the reason attractive forces decrease with increasing of the distance between the dipoles. So here the interaction energy is inversely proportional. That is inversely proportional to the distance between the polar molecule. So the dipole interaction between the stationary polar molecule, that is the proportional to 1 by r power 3. The first case 1 by r power 6. And that the between the rotating of polar molecules, the proportional to the 1 by r power 6. Here the r power 6, the distance between the polar molecule. The first one is the distance between the two particles. Here the distance between r, distance between polar molecules. So here besides the dipole interaction, the polar molecules can interact by London forces also. See the total intermolecular forces in polar molecule increases. Here the polar molecule, the intermolecular forces, polar molecules are increases. So this is called dipole interaction forces. The next third one is dipole induced dipole. induced dipole forces. Here, the attractive forces that operate between the polar molecules having a permanent dipole and the molecules lacking the permanent dipole. Here, the permanent dipole of the polar molecule induced dipole on the electrically neutral molecule by deforming its electronic cloud. For example, atom of that is A and B. This having a permanent dipole, a polar molecule, positive and del negative, that is partial charge. This having a permanent dipole, and the non-polar molecule like this. The non-polar molecule like this. This is non-polar. This is polar molecule. Polar molecule with a permanent dipole. Here, the polar molecule, one more time, that is the induced dipole is developed on the other molecule. That is, in the case of the interaction energy proportional to its what? That is 1 by r power 6. Here, the permanent dipole with polar molecule, for example, A, B. So, this case del positive, del negative, and this is the permanent dipole. Here, this is a non-polar. Here, the induced dipole in a non-polar molecule. Del positive and del negative. Induced dipole a non-polar molecule. Induced dipole molecule into non-polar molecule. Here, the dipole moment depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecule. See, that's mean the high polarizability increase the strength of the attractive interactions. So, these are called dipole, induced dipole forces. Then the fourth one is hydrogen bonding. Here, the hydrogen bond, that is molecules in which highly polar like NH, OH or HF bonds are present. See, the hydrogen bonding is regarded as being limited to nitrogen, oxygen and fluorine. See, but species such as chloride ion, Cl- ion may also participate in the hydrogen bonding. The energy of hydrogen bonding varies between, that is 10 to 100 kilojoule per mole. This is a quite significant amount of energy. Therefore, the hydrogen bonds are the powerful force in determining the structure of the properties of many compounds. Example, proteins, nucleic acids. The strength of the hydrogen bond determining the Coulombic interaction between the lone pairs of electrons, the electronegativity of atom, one of the molecule, and the hydrogen atom of the other molecules. That's mean you can see here HF, for example, HF molecule. This having the partial positive and partial negative. So del plus and del minus. Then another one more molecule of hydrogen, HF. So partially positive and the partially negative. So this positive and negative interaction will be there. This is the intermolecular forces. That means the electronegativity of one molecule and the hydrogen bond of the other molecule. So this is the hydrogen bond. Then intermolecular forces, that means the molecules are also exert the repulsive forces on one another. That means the two molecules are brought into close contact with each other. Means the repulsion between the electron cloud and the and that between the nuclei of the two molecules comes into play. That means the magnitude of the repulsion rises very rapidly and the distance separating, that is the molecules decreases. This is the reason that liquids and solids are hard to compress and these states of molecules are already in close contact. So therefore they resist further compression and would result in the increase of the repulsive interaction. The next is thermal energy. See, the thermal energy means that is bond arising from the motion of its atoms or molecules. It is directly proportional to the temperature of the substance. So measure average kinetic energy of the particles and the matter responsible for movement of the particle. So the movement of the particle is called thermal energy. Then the intermolecular forces versus thermal energy thermal interaction. Here already you learned that is the intermolecular forces tend to keep the molecules together, but the thermal energy of the molecules tend to keep them apart. The three states of matters are result of balance between the intermolecular force and the thermal energy of the molecules. So when the molecule interactions are very weak, means weak interaction. Do not cling together to make a liquid or solid unless the thermal energy is reduced by lowering the temperature. Gases do not liquefy on compressing only, although the molecules come very close to each other and the intermolecular forces operate to the maximum level. When the thermal energy molecule is reduced by lowering the temperature, the gas can be very easily liquefied. That is the predominance of the thermal energy and the molecular interactions like this: gas to liquid, then solid. So this case like this. So the predominance of the intermolecular interaction like this. The same reverse also, the here gas, liquid, then solid. Here the predominance, the predominance of thermal energy. And this is the predominance for the intermolecular interactions. So here already that is we are going to learn the thermal energy like liquid and gas. The solid state we will learn in the higher secondary level. The next is the gaseous state.